Hey everyone. So today I participated in Google Kickstart round two. So in this video, I'll be discussing the solutions to the first three problems. The last one I'm not able to solve, so yeah, we'll be skipping that problem. So let's get started. Going to the first problem. What you are given is let's take an example to understand. Let's not read the statement. So basically, what you are given is you have n cells. And what happens is you have two players, player one and player two. So the player one is a bot player and player two is zero. So you are playing the game, right? And in each step, what you can do is you can color a cell. Initially, all cells are uncolored. So you can color a cell, and you can only do that when the previous and the next cell are uncolored, right? So you can color the cell because this is uncolored and this is uncolored. But now you cannot color this cell in the next step because this cell, the previous cell is already colored. So that's how you make a move. This is also true for the boundary cases. So for this cell to color, only this cell need to be checked because it doesn't have any previous cell. Similarly for the last one. And it is given to us that the bot player makes the first move. Right. And how does the bot player play? So the bot player, as the name suggests, is a bot player. So it's not very smart. So what it is going to do, it's going to look for the first uncolored cell from the left side, which it can color, and just color that. It will not think anything else. So that's how bot player plays. And so the other player is you. So how you play? So you play in such a way that the bot player gets the minimum number of turns, right? So I'll tell you what I mean by minimum number of turns. So if we look at this example only, so let's say let's start the game. So the bot player will start from the left side. So it will find this cell is the first uncolored cell, and it has an adjacent uncolored. So there is no colored cell here. So it can color this. So the turn of bot player is over, and now you'll make a move. So you can choose. You cannot choose this because it is adjacent. So you can choose any one of these three. So let's say you choose this, right? In that case, your turn is over. Now bot player will get a turn, and he cannot choose this because these two are colored. He cannot choose this because this is colored, but he can choose this one, right? So the bot player will color this, and the game ends because there are no more things you can color just now. So the bot player actually got two cells to color, right? And now what you have to do in the game is you have to minimize the number of turns the bot player gets. In this case, you got two, but how can you do better than this? Yes, you could have done better. If had you colored this, if you had colored this, then the bot player cannot color this in the next step because this is colored. It cannot color this because this is colored, and it cannot color this because again this is colored. So in this case, the bot player will get only one turn. So that's how you can minimize the number of turns the bot player gets. So this problem is actually very easy if you think about this. Constraints basically you have 100 test case and you have 10 power 6 length just row number of cells. If you think about this, so the bot player is bot. So basically it will always put the very first cell which it can color. So if I color this, then this cell is gone. Now, if I color this, I'll make this cell gone, right? If I color this. But, so basically, I only impacted one cell, one new cell. But I could have impacted two other cells, right? How would I have done that? I can just color this, and this is also impacted, and this is also impacted. So I'm minimizing the number of possibilities for the first player. So the way you do that is whenever the first bot player makes a move, you try to make a move two steps farther from him. Okay, so basically three steps, 1, 2, 3. So you try to do it three steps farther, and then this way your five cells will be blocked for one possible move. Right. When I said you try to make because sometimes what happens is, let's say you have only three cells. In that case, you cannot go three steps farther, so you'll have no other option but to choose this cell. So basically, as you can see that this is a pattern. So for every 5 cells, the bot player get one move, right? So let's say if I had one more cell, then bot player will get a move. Add one more cell, this is already blocked because of this. It doesn't impact. So basically, if you think about this, for 5 cells, the answer is 1. For 6 cells, the answer is 2 because the bot player gets this chance also. You cannot do anything. And for 7 cells, this is your move. So again, for 7, answer is 2. If you think about this, so for 8, the answer is still 2 because this is you cannot color this. For 9, answer is also 2. Why? Because now instead of coloring this cell, I would have colored this cell. So this is unused now. This cannot be used. And this cannot also be used. So for 9 also answer is 2. For 10, the story is different because it's again a multiple of 5. So this pattern will repeat. So basically again, you cannot force the first player to make only one move. He'll make at least 2 moves irrespective of what you do. So this is the pattern. You can see this. So basically the pattern is answer would just be your number of cells divided by 5 and you take a seal of that. And how you do that, you basically just add 4 here. This is your answer if you're doing integer division. So it's just one liner basically. This is my solution basically. So you just do a seal. So sealing basically if you're dividing by x, then you add x minus 1 here and just simply divide it. You don't have to take seal and all that. I mean the inbuilt operations which might not result in a correct answer. So yeah, that's the second problem. That's the first problem. So we are moving to the second problem. In the second problem, what you are given is you have n players and students, let's say, and students, and each student has a rating level, right? So now a student, so there's a concept of mentor and mentee. So if I remove this, so there's a concept of mentor and mentee. Basically, so let's say students had rating A1, A2, A3, A4. Now A1 can become mentor of A2. A1 can become mentor, right? It can become mentor of A2 only if A1 is less than equal to twice of A2. So if the rating of A1 is not greater than twice of A2, then it can become the mentor, otherwise not. So for example, so let's say one person has rating of 10 and another person has 15. So 10 can become mentor of 15 because it is not greater than 30. 10 can become mentor of 15, right? And also 15 can become mentor of 10 because 15 is less than equal to 20. So you see, even though the player's rating was less than other player rating, I can still mentor that player just because this condition is satisfied, right? So for this case, I mean, they both can mentor each other. Now the thing is that each player wants to have such a mentor such that his rating is as large as possible, right? Number one, he wants a mentor, and second, the rating of that mentor should be as large as possible, as large as possible, right? That's the condition. So this is again like there's no such a specific algorithm here. It's just very simple. So what you can do is for each, so you can sort this whole list, and for each player you can find out using binary search what's the maximum rating player you can get, right? But there could be some edge cases. Yeah, so edge cases could be, okay, let's say, so what should we say? So let's say, so if I sort the players, let's take sorted players only, 3, 5, 7, right? And you do binary search for this. So you say, find me the largest number which is less than equal to 6 for this player. So it will point to this. So basically for 3, answer would be 5. For 5, the answer would be find me the largest player which is less than equal to 10. So it will give me 7. Let's say we also had 6 here, so it will give me 7 because that's the largest player. For 6, the answer would be 7, and for 7, the largest player less than equal to 14 is 7 itself. So you cannot take 7. You get my point, right? So a player cannot measure itself. So in that case, you will take the next smaller number, which is 6 in this case. Okay, so for 3, the answer is 5. For 5, the answer is 7. For 6, the answer is 7. Oh no, for 3, now the answer is 6 because, yeah, I inserted 6 in between. So the answer is 6. For 5, it's 7. For 6, it's 7. For 7, it is 6. So these are the answers here, right? Now, how did I solve this problem? So you can do this using array as well, but I used a map. So yeah, I used a map and I inserted all the elements and their counts in a map. And now I'm doing an upper bound. So I'm finding out first element, which is greater than my current value, right? So I'm finding the greater element. So I want, so basically what I'm saying is, okay, let's say I have some numbers. Now, for this number, I found out that this is the first number which is greater than 2 times a of I, right? So now if this is greater, so this should be smaller, right? So less than equal to, this should be less than equal to 2 times a of I. So this is my intended number. So yeah, I use upper bound. And now I say ki if that is the first element, I mean the very first element is greater, then it should be -1. Actually, this case will never happen. So yeah, it's kind of redundant because that I'll get at least that element. I think yeah, this will never happen. So then you do a then you do minus minus on that index, right? So now you have got the largest element which is less than equal to. And then you can just simply check some conditions. Now this is the logic for when that element is equal to my current element. So yeah, this is other special case I forgot to mention. So basically, let's say I think it's already covered. So basically, yeah, let's say you have 3, 5, 5. For 3, the answer would be 5. For this 5, the answer would be 5, and for this 5, the answer is again 5, right? So if the values are same, then you can simply take the same value. So I was doing this using a map. So yeah, that I had to handle separately. If you do it using, I think, arrays, then you might need not to. You can simply just go one step back and print that value. So yeah, I mean, it's just implementation, not going to deep dive here because I use the map and it doesn't look clean. So I think array could have been a lot more cleaner. Yeah, so going to the third problem. So what you're given is you have a palindrome string given to you, and what you want to do is you want to um, concatenate another palindrome string here in such a way that the final string is also palindrome, right? So let's take a look at this example. So this CD, CC, DC. Okay. So let's clear this. So you have CD, CC, DC. I think this is what they say. Yeah. So basically, it's the palindrome, right? So because first, last, same, second, second, last, third, third, last. So they are same. So this is the palindrome. Now you want to append something here, some string here, in such a way that that string is also palindrome, and the final string formed is also a palindrome. This is what I want, right? How do I do that? Just take a look. So my first thought was ki since so this should be a palindrome, right? And what should I do? So since this is a palindrome, and this is also a palindrome, the final is also a palindrome, right? So what I thought was ki I mean the only possibility this would happen is ki you append such a so since this is palindrome and this is going to match somewhere here, right? So this should also be a palindrome, right? This part should also be a palindrome. This is palindrome, this is palindrome, and this should also be palindrome, whatever the middle part is remaining from here. Now you might think so. Let's discuss some cases here. I mean, before I jump to directly the solution, let's discuss some cases here. So what I'm saying is, I'm saying we'll take some part from here, which is a palindrome, and then this is also again a palindrome. I'm saying this should be a palindrome, and then we attach the first palindrome here, right? So since this is palindrome, this is palindrome, this is palindrome, so this whole should be a palindrome, right? And this would be my new string, which I attached. Again, now the question comes to mind is what happens when, what about those cases where you take something like this and then for this string you attach something more like this. This is actually a bad case because you can do better than this. How you can do the, since you are given a palindrome, you just append that string only after itself. So that is actually, the worst case you can go to. Since you are given this, you can simply copy and paste the same string. So this is the worst case you can get. So this, right? You have an S palindrome and you just concatenate S only. So this whole string will be a palindrome. And you'll never go beyond this length. So that case where I'm saying, okay, I'll take some more character from the new string and then my new palindrome will match with this new match string. So that will never happen. That's a bad case. So the worst case is you append the string itself, right? And a better case would be you are able to find some substring, some prefix, which is a palindrome, and some, what do you say, the remaining part is also a palindrome, right? In itself, and then you put this prefix part behind, and so that is also palindrome. So this whole will be a palindrome. I hope you get the point here, right? So now reiterating again. So what I said was, let's say you have these characters. Let's say C1, C2, C3, C4, C5, C6. So we have these characters, and let's say this is a palindrome. C1, C2, C3 is a palindrome, and you are able to say that this is also a palindrome. Then what you can do is you will put C3, C2, C1 here. Now this is a palindrome because C1 matches with C1, C2 matches with C2, C3, C3, and we know that this is already a palindrome. So this will be palindrome. Now, what does the question say? The question say that it should be the shortest string. Okay, so it's saying that the string you are appending should be as small as possible. They're saying it should be as small as possible. So it would be small if this part is small, right? So if you try to reduce this part in such a way that if this is a palindrome and this part is also a palindrome, so you can just append C1 in that case, right? So this will not be there. So you can append C1. Right. I hope you get the intuition. So you start looking for, the palindrome from the left side. As soon as you find a palindrome, you say, is the remaining string a palindrome? If it is a palindrome, then yes, you found your answer. Then you can simply append this palindrome on the back. So that's your answer. So you look from the left side, the first palindrome found. If the remaining string is not a palindrome, then you keep your search going on. You're not going to stop, right? And if you reach end of the string, it means that you can simply append the same string itself, which is S plus S. This will definitely be a palindrome because both of these are palindrome. Um, I hope you do get the point. You look from the left. So the first pendulum you found, which satisfy both the conditions, you print that. And the way I solved this question is I used string hashing. So if you're not familiar with string hashing, this might be the time you get familiar with it. So basically, what you're doing is you are trying to form a hash. Now, if you want to read more about string hashing, I would recommend this blog on CP algorithms. It's really good. Mm. So the blog here is really good, and you and like for me, this string hashing concept is very useful for me because I can simply apply this over like most of algorithms. I don't need to remember KMP or Z algorithms and all. I can most often use this uh, string hashing to do what those algorithms can do. Right. So I'm not going to go over like how this is done. You can just read this article here. It's really good. Maybe try to solve a problem or two from here. Yeah, I've solved these two. I think so. These are really good. So basically, what I usually do is I do double hashing instead of doing single hashing, which chances are you might get a collision, string hash collision, and then you might get a wrong answer. So I do double hashing with two different prime numbers, two different modulus, and two different prime numbers. And so this drastically reduces the chances that you will ever get a collision. You can still get a collision, but it's very, very, very rare. So yeah, it's quite safe in computer programming contests. So so yeah, that's what I'm doing. Basically, initially I have a string S, and I take the reverse of that string. So yeah, so let's take the initial example only. I think we block note. Okay, yeah, I think this was stupid of me. There's no need to take a reverse of this because the reverse of a palindrome is the string itself. Yeah, so let's take an example CD CCTC. Okay, so this is a string S, and I took a string T, which is nothing but the same string. Okay, then like I did, I think kind of poor work, which is not required. Now I realize that, but it's okay. I mean, so what I'm saying is, I start looping from the front side. So now I'm at this position, let's say. So I'll say, what is the hash of this part, right? So what is the hash of this part? So let's say the hash comes out to be x1 comma x2, right? So x1 x2 are nothing but your numbers, hashes. This is using modulo 1, this is using modulo 2, right? So let's say this is x1 x2, and the hash of this string is what? Hash of this string is your, let's say, y1 y2. Now for t, I calculate the hash of this part because this part is similar to this part. So this is actually the reverse kind of if you think about this. So if the hash of this returns, because this is C and this is C, so the hash should be same, x1, x2. So, and for this part should be similar, right? So you'll get hash y1, y2 here. So you'll not get y1, y2, sorry, because DCC is different from CDCCY. So let's say you get something Z1, Z2, right? Now you compare, is this equal to this? Yes, they are equal. Is this equal to this? No, they are not equal. So yeah, this split will not work, right? So if you split at C, this split will not work because this is not a palindrome now. Okay? So you do this again. This time your pointer move to next position. So if I remove this, yeah. So now you are at D. So this is now your string. So you have to match this string with this string and this string with this string, right? CD is not equal to DC, so their hash will not be same. You'll get something here for next string. And here y1, y2. So again, you will skip this index. So you cannot do a split from here. Now, for third index, CDC, you'll compare this with last three characters of next string, and this you'll compare with this. Now you can see that these two are same, so you'll get the same hashes here. So if you get x1, x2, you'll have same thing here, and y1, because CDC is same, so yeah, you'll get x1, x2 also here, right? So now your hashes are matching. So this matches with this, and this matches with this. So you can see that this split you can do, right? So this is one palindrome, this is other palindrome, and you can just append other string which is your first palindrome, CDC, and this whole will be a palindrome, right? So your answer would be CDC, right? So this is how you do it. So this is what I did. So this code you can find on the CP algorithm. You can just learn this algorithm if you're not aware, right? So then I wrote the subhash function, which is basically given your hashes, the hash of the whole string, prefix hash, and given two indexes, you find out the hash of that substring, right? Now, for the two strings, I'm calculating the hash of substring part one, part two, and for the second substring also part one, part two. Then I'm just simply comparing. If I'm able to find, I just print that answer in the return. Otherwise, at the end, I know that I have not found anything. So the answer should be the string itself, because palindrome plus palindrome, same palindrome plus same palindrome equal to a new palindrome. So yeah, this should work. And yeah, indeed it worked. So yeah, that was the third problem. And yeah, so that's more or less the contest for me. I was not able to solve the last problem. And my final rank is 498, which is like, I think, not bad considering having top 500. So, yeah, but still bad considering yeah, I could have solved the last problem, and how many people did solve it? So, yeah, 230. Okay. Cool. So, yeah, I tried the last problem, but yeah, I'm not able to solve it. So, I'll look at the solution of other people, how they solved it. Yeah, hopefully, if you had any doubts, learned something, and it was useful to you. So I have not been very active recently in putting up videos, so I'll try to be more regular from like next contest onward, or yeah, I might also do some non-competitive videos. Yeah, I'm looking forward to it. So yeah, and do put your comments like if you have any suggestions or any recommendations of things I should do or I should not do. That would be helpful. So yeah, thank you very much for watching this video. See you in the next one.